Okay, so for this video, I'm going to advise that you get out a periodic table. You should have one that I've given you, and also hopefully you kind of read through the little bit of history information about the atom. So the atom, as we know it today, has three parts to it. It has protons, neutrons, and electrons. And we know that the protons and neutrons are in the nucleus in the center, and the electrons are orbiting around the protons and neutrons, so the nucleus. They're orbiting around it in different energy levels and different spots and different orbitals. Well, before, we used to think that an atom was basically a dense ball, that it didn't have any smaller parts, and now we know that that's not true. It does have smaller parts. Some of them are positive, some of them are negative, some are neutral. So, when we look down at the structure of the atom, we need to know the basic parts, where they're located, and also how to determine the number of protons, neutrons, and electrons. Okay, so the protons are a positive one charge, so they are positively charged. They have a mass of 1 atomic mass unit, so an AMU is its own unit. And that's because atoms are so small, that's the easiest way to determine the mass. So one proton is going to be 1 atomic mass unit, and the protons are located in the nucleus. The neutrons are also located in the nucleus, but they are neutral. They have no charge associated to them. But they also have a mass of 1 atomic mass unit. Electrons are not in the nucleus. They're in orbitals around the nucleus, and they're actually attracted to those protons, so that's why they continue to orbit around the nucleus. Electrons are negative, and they're very, very small in comparison to the protons and neutrons, so they only have 1 out of 1,836 atomic mass units. So its weight, its mass is negligible compared to the entire atom. So they do have a little bit of mass, but really it's so small and insignificant we don't even count that into the mass. We only count the protons and the neutrons as the mass. So an atom has mass, and that's going to come from the protons and neutrons. The charged particles are the protons, which are positive, and the electrons are negative. All right, so the protons are equal to the atomic number. So that letter Z represents the atomic number. So anytime you actually see that, I know it's really strange, but if you see a Z, that's indicating the atomic number, which is equal to the number of protons. And if you look at your periodic table, which let me do that, let me pull that out. All right, so now if you pull out your periodic table, and this is the one that I want you to get used to using because it's the one they give you on the AP test. So if you look at your periodic table, it has the element symbol. It also has 2 other numbers. The number on the top is the atomic number, so that's the number of protons. So Na, or sodium, has 11 protons, and then on the bottom it has 22.99. So we can say that that's close enough to be 23. So its atomic mass is about 23 AMUs. So when we look at this number on the top, the smaller number is the atomic number. And that is the number of protons, which never changes. So the atomic number will never change, because if you change the atomic number, if you change the number of protons, you're changing what the element is. So if lithium had 4 protons instead, it would actually be beryllium, not lithium. It changes everything about that element. It changes its properties. So the atomic number never changes. Okay? Also, when you look at the periodic table, you'll notice that the masses are given in decimal points. Well, that's because this is the average atomic mass. It's an average, so that's why it can be a decimal, not a whole number, which we will talk more about later in this in the next unit. All right, so the protons will be the number on the top, so that's the atomic number that never changes. And the number of neutrons, well, you're going to take the mass and you're going to subtract the number of protons. So if I were to look at sodium again, sodium has a mass of about 23. So for this, we will go ahead and round. There's a mass of 23, and there's 11 protons here. So the mass is only made up of protons and the neutrons. So if you take the mass, subtract the number of protons, that will tell you the number of neutrons. So I have 12 neutrons here. Same thing for lithium. Lithium, I have 3 protons because the atomic number is 3, and my mass is 6.9, so I can say 7. 7 minus 3 would give me 7 neutrons. So I have 7 neutrons, I have 3 protons here, and a mass of 7. All right, so something important to note is that atoms can have different numbers of neutrons. The protons, that'll never change, but the number of neutrons can be different. And if it's got a different number of neutrons, that means it will have a different mass, and it's called an isotope. So remember that word. So if it's an isotope, it has a different number of neutrons and a different mass. It's a vocab term that's important and may come up later on the test, so make sure you know that. All right, so electrons, well, if there's no charge, the number of protons and electrons are equal. So basically, if there's no charge, we say that it's an atom, because atoms have no charge, no overall charge. So if the protons and electrons are equal, because protons are +1 and electrons are -1, if they're equal, there should be an overall net charge of 0, which means it's an atom. If they are not equal, then it's an ion. It has a charge. So if there's a negative charge, that means you have more electrons, and it's called an anion. And if there's a positive charge, you have less electrons, and it's called a cation. So a negative ion could be something like this. So you'll see that it says like -3 on the top right corner. Okay, so it's a superscript, it's a small number that tells you that it has a negative charge, so that means it has more electrons. Well, if you want to know how many more, the charge is -3, so it has 3 more. If I look at this one right here, barium with a +2, well, if it has a +2 charge, it's a cation, then that means it has less electrons. I want to know how many less. It has 2. And this means that it has 2 less electrons than protons. The number of protons will never change. So let's look at nitrogen really quick. Okay, so if I look at nitrogen, nitrogen has an atomic number of 7. Okay, so if it has an atomic number of 7, that means it has 7 protons. That's not changing, because that never changes. If it's an atom and has no charge, it should just be 7 electrons. But if nitrogen actually has a charge of, let's say, -3, that means that there are more electrons than protons, and there would be 3 more. So it wouldn't be 7, it would be 10 electrons instead. So if we look at magnesium, magnesium has 12 protons, and if it has no charge, then it would have 12 electrons. But if it has a charge, let's say it has a +2, that means it has less electrons. It's always counterintuitive to what you think it should be. It's less. If it's positive, it's less electrons. If it's negative, it's more. So if it has a +2, it's less, and if it's +2, it should be 2 less. So it actually will be 10 electrons. Oh, and they actually have the same number of electrons here. Okay, so let's do a few examples that are in your notes. Okay, so you're going to see symbols written out different ways. So this way, you look at this number. So let me rewrite it so it looks a little bit better. Okay, so the numbers mean different things. This is the charge. So if it's on the right-hand side, that's going to be the charge. Now the top number here, this actually tells us something. It tells us the mass. So you don't need to look it up on the periodic table. And you don't want to, because it could be an isotope which has a different mass. The bottom number here is your atomic number. Please, 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 please make sure you write this stuff down, because you will see these symbols again. So if I see this number on the bottom, that's the atomic number. The number in the top left corner would be the mass, and then of course if it's on the right, it's charge. So for protons, neutrons, and electrons, let's figure it out. Let's figure out how many of each. So our atomic number is 20. It should be 20 protons. If we have a mass of 40 and 20 protons, that should be 40 minus 20, so just 20. Well, this one has a charge right here. It's a positive, so it should have less electrons. It's positive 2, so it should be 2 less than the protons, so it should be 18. By the way, I highly advise if you get to a point where you're like, I think I know how to do this, pause the video and just see if you are right. Try it yourself and then see if you're right. All right, so let's look at this one. Oxygen 17. So anytime you see a dash with a number like this, that dash represents the mass. So write that down. Make sure you know that if you see that, that's a mass. So I'm going to use this as my mass, not the mass in the periodic table, because it's probably an isotope. Okay, so I do need to look it up on the periodic table. So let's look up oxygen. Okay, so oxygen is right here. The atomic number is 8. We're ignoring the mass because it gave us a mass of 17, which is different. Okay, so we have an atomic number of 8. Remember, Z is our atomic number. All right, so protons, neutrons, and electrons. So we know the atomic number is 8, so we should have 8 protons. My mass here is 17. So 17 minus 8 protons should give me 9 neutrons. And for electrons, well, it doesn't say anything about a mass. I don't see a charge. It doesn't say anything about being an ion, so we assume that it's got the same number of protons and electrons. In order for it to have a charge, it would have this little number on the top, or it would say ion, which it doesn't do either of those things. So it should be the same number as the number of protons. All right, so we have oxygen again. Well, the number of protons should not ever change, so it should just be 8 protons here. It does have a charge, so it's -2, which means it has more electrons than protons. So it should have 2 more electrons than protons, so it should be 10. And then for the mass, it doesn't give us a mass here, so we're going to look it up on the periodic table. And I believe it was 16 on the periodic table. And it is. Right here, the mass is 16. And we're looking it up this time because it doesn't say what the mass is on the example. So the mass is 16. 16 minus 8 would give me 8 neutrons. All right, so, well, try this one on your own. All right, so we're going to look it up on the periodic table so we can get the atomic number. So iodine. Iodine is I. So always, as you're getting used to this periodic table, try to figure out what the symbol is first. And then if you need to, you can go ahead and double check, but you're going to need to know the basic symbols for sure. But you will know them, I promise you, after like a month or 2. Okay, so iodine is I. Its atomic number is 53. All right, so let's do protons, neutrons, and electrons. All right, so, and I've already forgotten the atomic number. It's 53. All right, so the atomic number is 53, so that means 53 protons. It has a mass of 128. I'm ignoring the mass in the periodic table because the mass is given. So 128 minus 53, 75. And there's no charge here. It doesn't say the word ion, so we assume that protons and electrons are equal. All right, so let's look at the next one. And again, you should try this one on your own. Okay, we have a top number of 133 and bottom of 55. Cesium, so it gives us the atomic number and the mass here. So the number of protons would just be 55. Neutrons, well, 133 is the mass, minus 55. So it's 78. And then there's no charge here. We don't see a charge right there, so we know that the protons and electrons should be equal. Okay, so make sure that you do know how to get number of protons, neutrons, electrons. Remember, protons never change. All right.